Alright guys, this is just going to be kind of an overview of interval notation for domain and range, mostly, but you need to know what all that is. I want to tell you that I am super spiffy now, and I have this handy dandy chalkboard where I can write better than I could on the PowerPoints for sure. But also I have this really cool thing that I don't think I'll have any reason necessarily to use it, so I'm going to show it to you anyway. I have this cool little thing. I can select something and then have a copy of it. Isn't that awesome? Okay, so I'm all technologied up now. So the first thing is, you're not actually calculating domain based on functions, but I want to kind of talk about that for a second to introduce the idea of a set. So if I had as my function, say this, then the thing is that I don't want to take a square root of a negative. If I take a square root of a negative, then it's imaginary, which I think we've already talked about, but you've definitely heard of before. And then we can't plot that. That's not, when we do these axes, these are real in both cases. So I need this to be positive. So this is the situation as far as domain. What I need is that is at least 0 because I can't take the square root of a negative. And then I move the 3 over and I come up with this. When I write this, that's a statement. X is greater than or equal to 3. It's a wish, but it's a statement, okay? So if I am looking for the domain, I'm looking for a set of numbers, not a statement. So statement, but what I need is a set of numbers. So one thing that's called set builder notation, which you've probably seen before, is X such that, which may be a colon or maybe a bar. It's the same thing. I put these brackets around it and it makes it a set. I'm saying all the guys so that this is true. So that means this is a collection of all the numbers where that's true. The real true way to write this is not this. This is what they teach you in school because you're almost always dealing with real numbers. The real true thing to do is say take all the x's, which are elements of the real numbers. So this says x is an element of the real numbers. So all the x's, all the real numbers, so that, and then you tell the rule. And this isn't what you're being tested over. I don't even think this is on the assessment at all. But this is kind of the way to get directly from a statement to a set. And it's also this one more so. When you get in 11th grade, there's some code that you're going to have to learn that's kind of based on this. So if I plant this seed now, that'll help us later. Okay, so if I draw it on the number line, here's 3 equal to, so I would put a solid dot, right? Let me get a different color chalk, a little bit fatter. White's boring. Okay, so 3 is included, and also things bigger than 3, so I can pick a little test point. I can pick 0 and 4. 0 is not bigger than 3. 4 is, so that means I need to go this way. And that's my set. So when I color in the whole arrow like this, I'm going out to infinity. If I draw the arrow in the left-hand direction, I'm going to negative infinity. So over here is infinity, outside this arrow, so to speak. So what I'm doing is I'm starting at 3 and I'm going to infinity. So we're trying to look at interval notation. Interval notation is where you have the end points, in our case 3 and infinity, but you have to decide if you want a parentheses or a bracket. So here's how you decide. The bracket means I've included it. So if I'm including 3, I want to go straight through 3, like that. Bracket. I can't ever get to infinity. So infinity will never, ever have a bracket. Well, Okay, that's a lie, but unless you're going to go to grad school in mathematics, this does not have a bracket. It just has a parentheses. So almost certainly never in your life will you put a bracket around infinity. And if you do, for the record, it'll be called omega. Okay, so anyway, if on my number line I had 3 open like that, then I would not want to get 3, but I would want to get everything around 3, like that. So if I'm not including 3, it's a parentheses. So you see this shows me kind of missing the 3. This shows me grabbing the 3, and that's a way that you can remember which one to use. So if I've got f of x equals 1 over square root x minus 3, I still need x to be bigger than or equal to, not 1, 3, because it's in a root. But if it's equal to 3, I get 0 down there in the denominator, and that's bad. So I actually need x to not be 3. So I need x to be bigger than 3. So the statement in set builder notation would be x so that x is bigger than 3, or x so that x is bigger than 3. On a number line, so parentheses, because I don't want to include it. Now what if instead it was something like we've been dealing with, like this? In this case, x can't be 3. So what I need to do on the number line is just miss 3. Everything else is fine. So I come up from the left and I miss it, and then I miss it and keep going to the right. So that looks like negative infinity to 3, parentheses, union 3 to infinity. Union means collect them together, unite them. Okay? This is intersection, and one way to remember it is if you've got 2 streets here, so let's say this is Park and Alma. If I'm standing right here, I'm on Park. I'm also on Alma. The only way to be on the intersection is to be on both streets at the same time. That's what intersection is. Union is the whole thing. Everybody on either of the streets. So that's what union means. So I stick them together like this. Okay. Now, one thing to remember is there's a very definite direction. So if I write A, B, and I'll just put a bracket and a parentheses. That means A, X, B, less than because the parentheses, greater than or equal to because of the bracket. Okay, so like when I had 3 infinity, I really had 3 is less than or equal to x is less than infinity, but of course it is if it's a number, right? So we don't write this part. We just write this part because all the numbers are less than infinity and all the numbers are greater than negative infinity. But when you have 2 numbers like this, the brackets go this way. The point that I need you to remember is that it's always going to be like this, okay? Maybe an equal sign, maybe not, but it's always going to be facing that direction. So if I were to write, say, 5, 3, this is 5 less than or equal to x less than 3. If a number is less than 3, it is not bigger than or equal to 5. So this is actually the empty set. So if you write these backward, you get an empty set of numbers. So it's going to be wrong if the answer was the numbers between 3 and 5. So this should have been written 3 to 5 if we were after that. Okay? So now that we've talked about this for a while, let me give you some examples. So if you see something like x bigger than 7, you can sketch a little diagram to remember 7 open circle because of that. And then you can pick test points 8, 6. The one that's bigger than 7 is 8, so you put it this way. And that makes parentheses. So 7, infinity. If you have y less than or equal to 9, put 9. Test points. 8 is the one that's less than 9, so you go this way. So this time I've got a bracket. Negative infinity to 9. And I just go left to right as on the number line. 7 is to the left of infinity. Negative infinity is to the left of 9, like that. So if you're talking about domain and range, and you have a graph, say, okay, so suppose, I should have kept my okay, so the filled-in circles and open circles work the same way on this type of graph as they do on a number line. So if I have something like that, then if I'm asked for domain, domain is always the x's. So here are my x's. If I project this thing down, which is to say squish it, if I squish this down, I bring a circle down to there. This all smushes down onto the line, so my whole line is covered over to here. And that's solid too, so it smushes down to a solid circle. So I have solid circle over to open circle. So I have bracket over to parentheses. The bracket's at -3, and the open circle's at +3. So this is my domain. So all I do is pretend that I'm squishing it and see where it goes down to. On the range, because it's a function on the domain, everything only goes to 1. On the range, I'm going to go this direction. So I get this open circle here, and all this filled in stuff here. That goes over to there. So I smush that over there. This one, I smush it over, it doesn't add anything, right? So I'm still just like, from here to here is where my function fits. And there's only an open circle coming over to there. So 1, 2, 3, 4 is an open circle. Down here I have -2, and that's not an open circle, because that got squished over from this continuous piece. So this is my range, and this should always be the leftmost number, and this should always be the bottommost number. Okay? If you see a quadratic, for example, so let's say that's at -3, the vertex is something -3, maybe 1, -3. Then what happens here, on domain, you can't see it all, but you know this keeps going over and up because it's a function. So in both directions, actually, it just goes on forever. If you go high enough, you'll always get that far over. So this is negative infinity to infinity. And remember, you can never put a bracket on infinity in algebra, or pre-cal, or calculus, or like, well on up. You don't. But then the range, if I smush this all over to the line, I cover everything up, infinity up, right? But I only go down to -3. So the range is -3 up to infinity. I'm going to do just a couple more, and hopefully that'll be good. So I'm going to do maybe 2 on this same grid, just so I don't keep being crazy. Okay, so let's suppose that I have now before I had a full dot and an open dot, and I projected them over, but the dot, there was stuff below it. In this case, there's not stuff below it, so I'm going to put that solid dot over there, and this open dot over here, and then up when I'm smushing to the x-axis, there's a solid one there, and an open one there, and there's nothing outside this box, right? This is a box around the entire function. So the domain, in this case, solid dot at -3, and then to the right, also 3. Apparently I like -3 and 3. And the range, 1, 2, 3, 4, -4, up to 1, 2, 3, 4. Open. Okay, so these both have parentheses at the end and brackets at the beginning because the left and the bottom are at this solid dot. So what if I have something that, say, starts here, and then does that? I guess I need some yellow chalk. Okay, so for the domain, I project this up and have a solid dot there. This goes on forever, so it actually just goes on forever. So the domain is -3, bracket, to infinity, open parentheses. The range, when I project this over, there's all the stuff below it. So that's the bottommost part, and because it's continuous, that's going to be a solid dot there. And that goes up forever, so up forever. So 1, 2, 3, 4, 5, 6, 7. Range is -7 to infinity. So hopefully this is enough to get you through that assessment and for you to kind of make some sense out of what this interval notation means. And if it isn't, then let me know and we'll make another video.